In this series of videos, we're using the openFrameworks C++ Creator Coding Toolkit, an XBox Kinect sensor, and we're going to build ourselves a 3D photo booth. So, join us as we step through video by video, grabbing data from the Kinect sensor, triangulating it, colorizing it, and saving it out to disk, and then building controls for our own 3D live photo booth. In this video, I'm going to be looking at using the XBox Kinect sensor for 3D sensing. In the video today, I'm going to run through using the Kinect 1414 or the XBox One Kinect sensor. This is a 3D sensor using infrared light for building real-time live 3D objects. What I'm talking about today also applies to the Kinect 2 sensor, which is the square boxier one, which is a later one, which is slightly better quality, uses a different approach to building 3D models using infrared light. But I'm going to do a separate video about some of the specifics around this, but pretty much all the things I'm going to talk about today on the Kinect 1 sensor applies to the Kinect 2, and all the basic principles are the same, though the setup is slightly different, which I'm going to be posting in a separate video. The first thing that I'm going to do is I'm going to go to my openFrameworks developer folder, and I'm running on Mac OS X. This applies to Windows and applies to Linux, but your process in making a new project will be slightly different. I'm going to use the project generator. You do your equivalent for Windows or Linux, and I'm going to make myself a new project in my apps folder. Called Kinect Sketch, and the thing that I need to do is add the Kinect add-on to it. This project generator scans through the add-ons folder that I have, and the Kinect version 1 add-on comes with the standard openFrameworks install. Inside you'll see all of the details about it, and if you have a look through the README file, there's some additional advice in running the project for Linux, for OS X, and for Windows. And also with the openFrameworks install in the examples folder, you'll find in the computer vision folder the Kinect example, which is a really great place to start, which will cover some of what I'm going through today. I'm going to start at the beginning, and we're going to build up and add additional pieces over time. So without further ado, I'm going to build my new empty sketch, just including the Kinect add-on. So I'm going to ask this to generate, and I'm working in Xcode, but you could be working in Visual Studio Code or Visual Studio, or just a text editor and compiling off the command line if you would prefer. So in my empty project, the first thing that I'm going to do is make sure that I have got included the Kinect header. So now my application knows about the extra capabilities in the Kinect code, and I'm going to make an instance of a Kinect in my header file. So the Kinect object allows me to and I'm going to call this a Kinect. So now I've made a Kinect object that openFrameworks knows about calling the utilities from the Kinect library, which describes how to interface over USB to a connected Kinect sensor. So I've specified that I want to make a new instance of a Kinect object called Kinect. And in my openFrameworks main file, I'm going to go to the setup, and the first thing that I want to do is I'm going to tell the Kinect that I want to register the RGB sensor and the depth sensor. If you have a look at the front the RGB sensor brings in a color image, just like a normal web camera, and the infrared sensor detects structured light that's being fired out from the infrared emitter. So it fires out dots in a pattern that diverge, and when they hit something they bounce back and they get read in by the sensor. And because they're slightly different in position, apart, you get a parallax error where the image between the RGB sensor and the depth sensor are slightly misaligned, and this aligns them. So the first thing that I want to do is set that registration. So I can go to Kinect and say set registration, and I want the registration on to be true. And then there are several different things that I can set the Kinect up to do, but the easiest thing is I say Kinect initialize, and there are various parameters that you can pass about whether you want to initialize the RGB camera and the infrared camera. And we're going to initialize everything, but you can set some of these parameters to false. Have a look through the documentation and you'll see more. And then I'm just going to say Kinect open and make a connection to the Kinect sensor. Now, just like when we're using a webcam or any other camera, we need to go and update the camera to say, please go and check if there's an image from the camera. So in the update function, I'm going to say Kinect.update. And then in the draw, all I'm going to do is I'm going to ask the Kinect sensor, have you got an RGB image? Can I draw it? And then also I'm going to draw the depth image. The depth image is computed and in black and white, it'll show us how far away it thinks different objects that it can see are. So I'm going to say Kinect draw, and I've got a couple of different options to draw. First thing that I'm going to do is I'm going to say draw at 0, 0, the RGB image, and we will say draw it Kinect dot width divided by 2. So I'm going to say draw the image starting at the top left hand corner, but just half the width please, and Kinect dot height divided by 2. So it goes and has a look at what the width and height of that image is and just draws it half size so we can fit them on the screen starting at top left. And if I draw that right now, run this, compile it, we should get just the RGB image coming from our Kinect sensor and being drawn on the screen. So here I have my RGB image from the Kinect sensor. I'm pulling it out, it's being drawn to the screen. That's great. So let's stop that, and I want to say Kinect dot draw, but this time I want to draw the depth image. And Xcode is helping us out here by saying what it can find. So I want to draw this across from where I've drawn the color RGB image. So I'm going to say start drawing at Kinect.width divided by 2. So it's going to go halfway across, but I want it to be starting at 0 at the top. And then again, I want it to draw at half the width and half the height, and let's have a look and see what we get. So it compiles, runs, and I can see that's fantastic. On one side I've got the RGB image, and next to it I have the depth image. And as you see, if I bring my hand closer and closer and closer, it's very, very white, and objects further away are darker. So the black pixels are the farthest away and the white pixels are the closest. And I could scan through this RGB image, the grayscale image, and use that to indicate white pixels close, black pixels far away, and then calibrate how far that is. But we can actually ask the Kinect sensor for that straight away. So what I've got here is great, but I want to do something a little bit more with it. What I'm going to do is I'm going to build what's called a point cloud. So I'm going to add here at this point, I'm going to say when I press a key, I want to just draw a point cloud. So I'm going to use a switch statement, and I'm going to say get the key, and if I press the P key, I want to set a Boolean to say please start drawing a point cloud. I start my Booleans with a B, so I know that it's a Boolean. It just helps me out. You can call this anything that you want. So when I press the P key, I'm saying if point cloud Boolean is true, make the opposite of it, make it false, and vice versa. So it'll work as a toggle when I press the P key. So I've made up this variable. Now in the setup, I'm going to start it out as false, and because it's global within my app, at the moment it can't recognize it, so in the header I'm just going to add this in so it's available to all the functions within my openFrameworks app. So now, just open this window up a little bit. I have a Boolean saying draw point cloud. When I press the P key, that will go from false to true. So in here, I'm gonna say if draw point cloud, else let's tidy this up a little bit, and what I can do is I'm going to select everything, go to the editor, structure, re-indent, keep this tidy and reasonable, put some comments in here, draw debug images to screen, so this will draw my RGB and my depth image, and in here I'm going to draw the point cloud. And what I want to do is I want to scan through every pixel in the depth image, that black and white image that we saw that's coming back from the depth sensor, and say how far away is this, and it's going to give me an X and a Y and a Z position, and that's the important point. It gives us depth. So the best way for me to hold that is to build a mesh. And I'm going to use the openFrameworks predefined 3D object, which is a mesh, and it starts out empty, but it can contain XYZ values as vertices that we can then join up with indices. So we can make lots and lots of dots to say these are the points in our 3D object, and then we can also triangulate them by saying which point is joined to which point to turn those into surfaces, and we can do additional things with it. I've done a couple of other videos about that, and there'll be some more stuff coming up soon. But have a look at the OF Mesh video, which should be linked somewhere on the screen about now. What we're going to do first is we're going to make a new OF Mesh, and I'm going to call this point cloud. And we want to loop through all the data that we've got, which is X and Y data, and then add in the Z data to make 3D points. So I'm going to make a loop. So I'm going to say for int, and we're going to count across, and then down line by line by line by line. So I'm going to loop through all the Y values, line 1, line 2, line 3, line 4, line 5, etc., and then all the X values inside it. But we'll actually turn out with X, Y. So we'll start with Y and loop through the Zs inside it. So I'm going to say integer y equals 0, and then y, we're going to keep looping while y is less than the width of our image. So I'm going to say connect dot width, and then I'm going to say y plus plus, so increment it, and then go into my first loop. So this will loop across through each of the lines running down. Sorry, this should be connect height. So it'll loop down one line after another. And then inside that, I want to loop across all the pixels inside my image. So I'm going to say for int x equals 0. And then I want to say the condition is x is less than connect width, and then I want to say x plus plus. And in here, I'm going to grab data from my Kinect sensor and put it into my mesh piece at a time. So I'm going to say at this point, I want to add to my point cloud, and I want to add a vertex, and it wants to have a vector 3 object, something x, y, and z, and I'm going to get that by saying Kinect.get world coordinate, and that allows me to get what is that coordinate in space at this point in your two-dimensional depth image array. So I'm going to say get the world coordinate at x, y. So this command asks the Kinect, give me the 3D coordinate at this xy position in your depth image array. And it will pull that back, and then I add a vertex, a point, to my point cloud. Now the first one I add in is going to be the first one in there, but it's going to loop through all our width times height points, which is great. Now, I'm going to run that in a moment, but what I need to do is when I build this point cloud, I need to do something with it. So when I draw, I'm going to run one loop after another, and at the end I have this point cloud. And what I'm going to ask it to do is very, very simply point cloud dot draw. This isn't going to give us a very great result, but this is the very basic of it, that we pull data out of the Kinect sensor, we put it into a 3D object, and now we're just asking the 3D object to draw those points that are in it. And every frame that the Kinect sensor has got new data, we update that shape of the mesh by making a new one. So if we draw this now, compiling away, we have our RGB sensor, we have our depth image next to it, and when I hit the P key, I am in debug, and I hit the P key and I come back. At the moment we can't see anything because it's drawing it in a completely different place. And because I'm trying to draw a 3D object onto the screen, what I'm going to do is I'm going to set up a couple of things with the camera. Now, to make this a little simpler, I'm going to take my point cloud building mesh and drawing, and I'm going to put it into a new function. Otherwise, my draw routine is just going to get bigger and bigger and bigger. So I'm going to go to my header and define a new function. It's void because it's not going to return me anything. I'm just going to say grab the stuff and draw it, and I'm going to call it draw point cloud. I'm not going to pass it any parameters, and that's all I need to do. So I defined a new function, doesn't return any information, doesn't get any information, and in my CPP file down at the bottom, I'm going to say here is the actual definition of everything. It's inside OF app. It's called draw point cloud, and I'm going to take my loop that I've made out of my draw function and call the new function that I'm building, and then I can put all my stuff down here, paste it in. So we start drawing the point cloud. The first thing we do, we make a mesh. We loop through building this mesh from all the points. We draw the point cloud, but what I want to do first of all is I'm going to move things around in 3D a little bit, so I'm going to use OF push matrix to say freeze whatever else you're doing in the 3D space. I'm going to do some stuff and move things around, and then I want to return it back to normal. So we push matrix at the beginning, we're going to do all our drawing stuff, and then OF pop matrix at the end, which has nothing to do with the matrix, the movie. So it freezes where we are. So I'm not going to mess around with other drawing routines that I may put in, and it makes my my whole code a lot less brittle. I'm going to draw the point cloud, but one thing that I know is that the point cloud is going to be right-centered, so I'm going to push it and translate. So I'm going to use OF translate, and I just want to move back. So I'm going to go back like 1,000, and instead of just drawing the point cloud, I'm going to tell it just to draw the vertices. So it's only going to try and draw the dots that are inside it. Now, one of the things is the dots are going to be drawn very, very small. But we're going to come to what's going to happen in a moment. So hopefully this should let us see point cloud. And then I'm going to put in the OF camera controller. So there's our point cloud. Here's our debug, RGB image, depth image. And when I press the P key, I get live. I can see I'm getting my point cloud. But it's drawing it in one place, and I can't do anything to have a look around. So what I want to do is start putting in some controls so that I can have a look and see what's going on with my depth image as a 3D object. So what we've got is in our header, we included the Kinect header file so that we now have all the capabilities from those libraries about how to address a Kinect sensor. We made a Kinect object, and we set up a Boolean so we can see a debug or draw a point cloud. In the header, we registered the images inside the Kinect, we initialized it and opened it. In the update function, we just ask, is there new data from it? And then we can draw the images from it and the depth image, RGB in the black and white, to screen. Or we made a new function called draw point cloud. We put a switch statement in saying if we press the P key, make the Boolean true or false for drawing a point cloud. And if that's true, we run this function that we wrote, which makes a new mesh, loops through all the X pixels and the Y pixels, pulling them from the world coordinates of the Kinect, which returns an X, Y, Z position, and we add those as vertices into our point cloud mesh, which starts off empty. And then we just did a simple routine to freeze where everything is in the 3D world, move away, draw our point cloud, unfreeze it, and then we see it on screen. In the next video, I'm going to look at doing more things with this and how we can use the EasyCam to be able to manipulate it and color our point cloud to do different things. So join us on the next video. So if you've liked this video, please subscribe to the channel and like, and leave a comment below telling us what you'd like to see and any feedback, improvements, any thoughts, and also the kind of stuff that we can help you out with in coding for artists.